So today I will talk to you about the different search approaches and strategies that are available in OpenSearch, open source. You can also ask me about Amazon OpenSearch service, so the manager service in AWS if needed. For that, I'll go straight to the topic. Mainly in search space, we have two types of search: the sparse retrieval and the dense retrieval, right? Retrieval or search. The sparse search or sparse retrieval is powered by BM25, OTF-ITF algorithm. In this space, we have the vanilla search, the usual keyword search, match search, that will basically match the keywords in your search query versus what you have in your documents, basically. Simple match. The second type of sparse retrieval that we recently introduced it in this service is sparse retrieval or sparse search. In sparse retrieval, you will be able to take advantage of the keyword search capabilities, latency. At the same time, you will be able to augment your keyword data with similar terms, similar semantic terms that may be basically more related to the intention of the user, basically, okay? If we go back to what is search in general, is to understand your user's intention when they are on your application or when they are searching for something. It's not the keyword in itself, but what is the intention behind. So the sparse retrieval will help to generate similar terms as what your user are looking for. At the same time, you will run BM25 algorithm. And the second space is dense retrieval. And dense retrieval, so they are powered by KNN, Key Nearest Neighbors, or ANN, which is approximate search. To give you a quick idea, I think this one. To give you a quick idea about what's the difference. Okay. To give you a quick idea about what is the difference between KNN and ANN, do you have anyone has the answer? Anyone familiar or knows what's the difference? You, I will not look there. Okay, so KNN is the brute force similarity search. So in embedding in vector space, which is the dense retrieval, the data is presented as vectors, as embeddings. Basically, what is embedding is an array of floats, all right? And these array of floats are available in high dimensional space. It can be thousands of dimensions, all right? So the KNN will try to find out what is the nearest vector to your query, to the vector that represents your search query, all right? The KNN will do exact, it's not exact match, but it will be exact search, basically, okay? It will go across all vectors to find out which vector is similar or more similar or closest to your search query vector. The ANN, however, it's more intelligent way to traverse, let's say, the embedding space and probably not go with brute force, will not go through all embeddings or all vectors, will find out what are like different strategies to find out what are the most closest vectors to your search query. This is where we talk about HNSW, IDF, the algorithm that are used in ANN. I will not go through that, but we can have like discussion about it later. So in dense retrieval, we have the semantic search or vector search, basically. Semantic search is one example of vector search. All right, in vector search, you can search text, you can search image, you can search audio, and all of these data formats are presented in vectors or embedding, as I explained. Then we introduced recently multimodal search. Multimodal search will allow you to search by different type of data format, let's say. You can search by text, you can search by image, you can also search by both text and image. I will show you a demo in a few slides how is that done, basically. Then we have a combination of the two words, the sparse and the dense, which leads us to the hybrid search. The hybrid search, you can, or you will be able to run the keyword search, okay, along with semantic search or vector search. And here, so it is powered by both BM25 and Canon, so you take the best of the 2 worlds. Last but not least, the RAG conversational search that is available in OpenSearch, open source right now. And here you can basically leverage BM25, like the keyword search or vector search, along with your LLMs to provide context, to reduce hallucination that we were talking about, to provide whether the right context or data that is more recent or data related to your business, etc. So your RAG solution will be more fit to your business use case. So I'll be sharing with you a demo that will present you the sparse retrieval, dense retrieval, and hybrid search retrieval. All right, we'll not go through the RAG today. So the solution that we'll be presenting, it is a web application, basically Streamlit web application that is hosted on an EC2, and it connects with OpenSearch as a backend to retrieve the data or embeddings from OpenSearch. Then our machine learning model, the embedding models, are hosted on SageMaker and Bedrock, and we'll use the ML connector capabilities in OpenSearch to connect to these models that are hosted outside of OpenSearch. You can also use actually machine learning blueprints for Cohere or OpenAI that they are available as well in the open source. And in today's demo, I will show you like use cases with SageMaker and Amazon Bedrock for Titan multimodal search. So the ML connector or neural search here, it's exactly what we were talking about in the previous example. You will need to register the model in OpenSearch and then deploy the model in order to use it basically in OpenSearch. And this is what also will enable you to use natural language query when you query the data. You don't need to add another external component where you translate the query into embedding and then you search that embedding or that vector. OpenSearch takes care of that within the service in itself. And then so in OpenSearch you'll be able to create index pipelines where you will do your mappings, saying like these kind of fields you would like them to be Canon type of fields, the embedding type of fields, and the search pipelines. The search pipeline contains processors, basically processors that will process your search results. There are different type of processors that you can leverage in search pipeline. I highly recommend that you check it out. And for the demo, we are using specific processor for hybrid search. Okay, so for the demo, I have a recorded demo. However, I will go with the live one. I want the solution. All right. So this is the Streamlit application. Here we'll be able to enter the search query. We'll upload an image for multimodal search, and we'll be able to run keyword search, vector search, hybrid search, multimodal search, and sparse search. In the left-hand side here, so basically we can active the sparse search. We'll also be able to fine-tune the hybrid search. Why I'm saying this? Because in hybrid search, you give different weights to BM25 query and the vector query. You will be saying, I want to give more importance to the results or relevancy that is provided by the semantic search versus what is provided by BM25. And you will also be able to change the normalization and combination techniques because BM25 and Canon has different scoring mechanism, and basically the score in BM25 can be unlimited, and in Canon is different. It's like up to 0 and 1. So you need to normalize and combine the scoring from vector search and BM25, and this is usually done outside of OpenSearch. Before supporting this feature, you will need to build the normalization and combination outside of OpenSearch in your application. Now you will be able to have it within OpenSearch in itself, so you don't need the overhead of managing the combination and normalization outside of OpenSearch for hybrid search. And then you'll also here, so as I mentioned, we support in this solution a model that is deployed on Amazon SageMaker, and another model which is Titan that I recommend you check it out. It's for multi-modal search, so it will create the same embedding space for text and image that we'll be using. So I will be demonstrating Bedrock right now, the Titan model. Alright, so let's start with an example. I would look for, I'm a woman that loves shoes, so I would say trendy footwear for women. And we'll start with the keyword search, okay? Alright, well, I did not get any shoes. I got a jacket and I got glasses. I have some shoes here, okay, but why I'm not getting shoes here? This is because, as we explained it, the keyword search will simply match the keywords that are available in the query here, and try to match what the words or keywords that are available in the image caption. And in the image caption here, we have women, we have trendy, so the keyword search for it's like relevant document. Does not understand that I need shoes. Just understand that, hey, we have matches here between trendy and women, so this is probably a relevant result. Now let's see how can this be improved with sparse search. Click on this one and regenerate results. All right. Now, sparse search, as we explained it will augment your text with similar words that might be more relevant to user intent. In this example, we are using a pre-trained model that is supported in OpenSearch. It is a byte-encoder model that will generate terms for both query and documents. What do I mean by that? So this is the search query, all right? Trendy footwear for women. The sparse embedding model created for me or generated for me this list of terms that might be relevant to the search query. And here it's like a pair that is generated. So we have the term and the weight of the term. And the weight here is taken into consideration for the relevancy. This is for the query. And same thing for the image caption. So here under each document, I have a list of terms that are relevant to the image caption with the weight of each term, basically. So here, for example, we have sandals. That's a footwear, right? We have summer, sleek, elegant, which is relevant to trendy, for example. All right. Now, with sparse search, we only see shoes, right? So it understood that I'm looking for footwear and it is for women. So this is one way on how you can improve the keyword search by using the sparse search. Now let's check the vector query. Let's generate the results. So just to let you know, so in the vector search here we are creating the embedding for the image captions, all right? So we are not using the embedding of the image in itself. So trendy footwear for women. So here we have different scoring of images, all right? So I got this image in the sparse search, and now I have it in the vector search. However, the relevancy is different. The scoring is different here. I even have like a sneaker. So the vector search says like, yeah, sneaker might be trendy right now, probably. So it got me that image. Right? Now we move to the hybrid search. So I will generate the new results for hybrid search. Okay. So the hybrid search, I got the same two top elements. However, the rest are different. Okay. And oops, I have a jacket here. Okay. Why is that? How can we improve this? This is where the fine tuning happens. Okay. So here I would say I want to give more weight to the vector search, to the semantic search. So the weight, like just to let you know, it should be between 0 and 1 for both queries. So if I give 80% weight to the vector, it will only leave 20% to the keyword search. So now I'm giving more weight to the vector search. For the normalization and combination, I will leave the same techniques right now, and will regenerate the results. And I only see shoes. And trendy shoes, not bad. So we've seen how we can improve keyword search using sparse search. We've seen vector search. We've seen hybrid search that will use or leverage both the power of keyword search and vector search. And this is where you basically will focus on your business, what will work best for your users. You always need to think backwards from your users, what will match best their request. Now we move to the multimodal search. And for this, just a reminder, we are using the Titan model deployed on Amazon Bedrock, and we regenerate the results. And so, as I told you, for the multimodal search, we can search by text, we can search by image, or we search by both. So let me try to search by both. Summer footwear, okay. Okay, so now as an input for multimodal, I have the text, I have the image embedding, and I have different type of shoes that are recommended by the search query. So first thing, you see that most of the search results here are towards summer shoes, okay? Which is basically, I did not specify that in the text, but it got understood by the image, basically, the characteristics in the image. And this is where the power of your machine learning model that you are using is seen, basically, or witnessed, basically. And even the type of the shoes here, for example, the leather type, the structure in itself, the style, etc. So I hope it's clear for you the different type of searches. We've seen how we can improve each one of them, basically. And now I will just leave you with these QR codes. So you can deploy the same solution using the first QR code, and it is available in AWS samples. It uses, however, Amazon OpenSearch service, and you will be able to check out like the different use cases, try with your own data, try to deploy your own machine learning model on SageMaker, and create the connectors with OpenSearch. The second QR code in the middle, this will direct you to the documentation basically of OpenSearch, like how you can learn more about each type of search and when to use each type of search. The last QR code, so OpenSearch project has been busy last year, same for the service. So here it will give you all the new features, what is coming also in OpenSearch open source, around OpenSearch AI and machine learning topics. Thank you. Questions or pizza?
I have a question regarding the type of models that you have displayed. I see that you displayed them in one next to the other, so it means that you cannot rank them, and the ranking or the worth of the model will be based on the business use. So we cannot say that Victor is always better than keyword, or we cannot always say that.
Yeah, no, it's based on your application, your business model, and you need to know your users. You need to know what type of searches your users are doing in your application. You need to also understand there are some more advanced techniques that will help you learn from your users, basically. In the sense, when you deploy in your search application, let's say, you have a list of documents that will show up after a search, right?
Mm-hmm.
So basically, you can measure the relevancy of your suggestion based on the customer intent by capturing which answer your user picked up from the suggested document, for example. You can capture that so you can have an understanding of each of your users, what are their preferences, and basically you can take that as a test later to choose the type of model and especially the type of search that you need.
Okay. That was my first question. My second question is, when you were talking about the multi-model approach, I used to think that when you're ingesting your data, the model that you use to embed your data to ingest it should be the same model that with which you ingest your search query in order to search it against your index. So when you say multi-model, it's model by type of data. When you static model for video, static model for pictures.
Okay, so for multimodal search, the machine learning model need to be have the capability to create the same embedding space for different type of data. So the Titan here that we are using is a multimodal Titan model that will create the same vector space for both text and images, basically. Okay, so you will use the same Titan model for your input and also your search query as well. So the search query for us in this use case was composed of two, text and image. Okay, but you can also use one of them. You don't necessarily need to use both all the time.
Thank you very much for the talk. I don't know if it works. Yeah, it works. My question was about sparse semantic search.
Sparse search?
Sparse semantic search. You talked about it like it was released in not the last version but the version before the last of neural sparse search. Okay. Alright. Is it better to use the model only at ingest, so when we are creating our vectors, or is it better to use our model also at query time to create term expansion, I think is the word?
Yeah. So for this sparse vector, you have the option to use a sparse model to create or generate those terms only for documents or for both documents and search. I will not say one is better. You need to consider a few things, latency, for example. So if you use the sparse model to sparse the query, for example, that might have more latency, basically, in terms of search speed. So most likely, customers will more only use like the document encoder, but it depends. Like we have fine tuning that you can leverage for if you want to use both.
Okay, thank you.
great talk.
Sure.
Very detailed, especially the slide.
Awesome.
I guess you mentioned that you can't say one is better than the other, but based on experience, if you can mention two of these, what were like some sectors or use cases you found they had some really interesting results?
Okay, so from my customer experience, I would say the keyword search works very well. Alright, that's I would say the goal of search. That's the main point, basically. So that works very well. There is many different ways to improve the relevancy, to re-rank the documents, etc. The sparse neural search can also be like lightweight change versus if customer has already keyword search, moving to vector search, for example, that can require a lot of changes. So they would say, okay, so it's easier for me to go through neural sparse search instead of the dense retrieval method. For new use cases, it's usually the dense retrievals that will be like the first place to go, because you have different capabilities, you have more features, you have better understanding of the user intent, you have more ways to improve the relevancy, you have more ways to basically different machine learning model that you can use for the embedding, etc. So, and it also can open the door for new use cases like RAG, and other machine learning use cases, basically. So it depends. Hybrid search is also very powerful. We just need to understand your business and your data as well to be able to fine tune and find the right parameters to improve. It's very powerful because you leverage both here. And there is also few new features that we released, like efficient filtering, etc. That you can use with hybrid search. So.
Thank you.
Would you agree with me if I say that for an observability use case, either for logging or security, keyword search is more than enough, and using vector is just a plus?
Depends what you want to use. What's the use case exactly that you want to build? If you want to build the RAG with observability, that's fine as well. Like the machine learning assistant that we introduced in OpenSearch is a conversational search. You ask question, natural language question about your data, and you get responses. You get graphs, you get text, you get summarization. As a developer, sometimes you don't have the time to go in each graph, each dashboard, like, and create a report for your supervisor. Basically, you just need to have something quickly generated for you, understanding your data quickly enough, and send out the report to your supervisors within the few hours, basically. So it depends. It depends on the use case.
Can I respond on the new model that you have developed for the observability?
What is it?
The new model that you have developed for the observability.
It's not a model. It's a machine. It's an assistant that you will find on OpenSearch dashboard, where you can ask your natural language queries, basically.
So in terms of cost of your resources, is it costly?
Yeah. So it's still in preview, so we don't have the cost model shared yet.
We still have a little time to ask questions.
Thank you.
On reste là, hein, si vous avez d'autres questions.